Hello everyone. Hello again in this new tutorial. In the last tutorial, we showed that how to create a rip-down rules model to query a relational data model, a relational object, basically the robot object we queried about the contained objects of it. Now in this tutorial we would use the same example, but we will now use another feature of the Rebel Down rules, which is the Rebel Down rule decorator. Now the Rebel Down rule decorator does for us is it removes a lot of the boiler code that we need for creating case query and then creating a Rebel Down rule model and fitting calling the fit case of that. So if we look at our previous example, we had like we needed to create our model here, we need to create a case query, and then we need to fit the case on that. But now with the decorator, you just need to say I'm in fitting mode and just call your method that is decorated with the other decorator, and it will internally call the Rebel Down rules model to give the output of this method. And if you want to run it in classification mode, you just set fit to false, and then you just call the method as usual, as if you're just using the method, right? And then the result of that is the result of our RDR. So basically your query in this case is I'm querying the output of the function, and my case is whatever this function takes as input. And if we go there, we will look at what's currently there. So we have our robot, which inherits from our original robot model. So our original robot model was from the previous example, which was just a physical object that has parts inside it, right? And what we did currently is that we added to it another attribute, which is our decorator model, which says, okay, we have this RDR decorator, this is our directory where the models are saved, this is the output type, this is method exclusive, and whether we are in fitting mode or not. And then by default this is set to false, and then we have here a new method that is a method in our class. This method is supposed to get us contained objects, and currently it's empty because we basically replace its implementation by the rules in the Rebel Down rules model. So we decorate that method with our decorator. So we call just the containment rdr.decorator on that, and that will then internally then run the rules on this method, and the input to this method, which is basically the instance of the robot, is the only argument which will be used then as our case in the Rebel Down rules. So if we go back to our example, we will see that here this should internally call the Rebel Down rules, and it will then, if it has no rules, it will prompt you for a value because it has no value currently. So let's run that and see if that's the case. So we see here we have none as the current output because it's a function and the function is empty, and the current output of the function is just none. So our case here has the self, which is the robot. Here self is postfixed with underscore just to not be confused with the built-in self value. So here we can write case. We can see that our case is actually a dictionary with the self key, which is points to the robot, and the output, which is currently none. And actually the case is like a dot dictionary, so you can actually access self like this as well, which will give you the robot. And also you can access the output as well, right? So and you can also check for the current value, which is currently none. Okay, so now we want to write a rule for this, so we again press the edit button, opens a template for us that we can fill out. You would see now your arguments are the arguments for the function, which is the self, postfixes with an underscore, and this extra argument you can ignore. It's the output of the function. You should never use this in your logic anyway, so this is just there as part of the case dictionary, right? So we are just interested in the self, which is the current arguments of the function. So what we will do here, similarly to the previous example, I would say that our contained objects are the basically that. So for every part in the robot, give me the contained objects and put it in my contained objects. And then I would return that. And then we go back to our GUI and then we load that. We test that everything is good. Here, be careful that you have to give it the flushed out dictionary, so you put these double stars to flush out the dictionary arguments into the arguments of the function, right? So, and then you just press enter. We see that this is the expected result, so we are happy with that. We press the accept button. Then it's asking us for conditions for this value. I would say, similarly to the previous one, that basically we have some parts in our robot, right? So self dot parts is greater than 0. Okay, we go back to our GUI, we load that, we test it out. Here is the case, and that's correct. So we accept the result, and it's happy. So if we run that again, it should now give us already the classified result. Yes, so we find it here. And if you press the rule tree, you would find that there is a rule and it already fired. So that's exactly what we wanted. So thank you for listening and see you in the next one.